Here's another hello from West Virginia. Nope, still not, but what we do have is joke of the day, and I know you're ready and waiting. So what happens to a frog's car when it breaks down? I mean, a frog's car, when it breaks down, what happens? It gets towed away. Because a frog's a toad, a toad. I love these. And the other thing that I love is evaluating functions. So let's take a look at how to evaluate functions. Now first let's review the definition of a function. A function is a relation, so it is a subset or a subcategory of a relation. So you have relations, and then relations that have certain special characteristics become functions. So these relations are the ones in which for every x value there is one and only one y value. Remember, we had these pictures that would help us remember this, and I said the easiest thing to do is to identify what is not a function. That's the easiest thing. What is not a function is this picture right here, and I told you to burn that picture in your brain. Whenever you have the same x going to two different y values, that is not a function. Everything else is a function. So when you have the same x going to the same y, yep, that's a function. When you have different x's, but going to the same y, yep, that's a function. But when you have the same x, in other words, the same input going to two different outputs, that is not a function. But once you've identified that you have a function, because it is special, that function, we give it special notation. Now understand that most of the time when we're talking about functions, we are talking about equations. I illustrated in the previous video about a function machine, and we looked at various strings of ordered pairs that gave us functions. Typically, functions indicate like a graph. Most graphs can be identified, well, all graphs can be identified by an equation. So most of the time when you're talking about functions, you're talking about equations. So let me give you an example of an equation right here. This is a line. It will graph a line. It's a linear equation. But once we've identified that this particular function, or this particular relation that is, when we've identified that this particular relation does not do this, that whatever x I put in here, if I put the same x in there, I don't get two different y values. When I've identified that this does not happen, this suddenly turns into a function. Well, to identify that it's a function, what happens is we take this y right here and we replace it with this character right here, the f of x. And it is read as f of x. You're used to that when you see a parentheses and you see something sitting right up against the parentheses, you're used to that indicating multiplication. This does not in any way mean f times x. That is not what's happening there. This is now notation, and it simply means it acts like a y. So therefore, when you see something like this and you see this f of x sitting right here, you think of it as a y. But this is indicating to you, oh, this one's special. This one's a function. And because it's a function, I know that's not going to happen. And I know that for every input value, there's going to be one and only one y value when you see something that looks like this. But remember, f of x acts like a y. But what it does is it says, okay, whatever's inside this parentheses right here, I'm simply going to substitute that value into my function, and I'm going to evaluate it by following order of operations. So for example, if I have this function, f of x equals 4x to the third plus 1 divided by x to the third, and I'm told I want to evaluate it for f of 2, f of negative 2, and f of negative x, then what I'm going to do in order to evaluate f of 2, I'm simply going to say, well, this was an x. See, it was an x. Actually, right here, it was an x. So that means wherever I see an x, I'm going to put a 2 in its place. Well, I see an x right here, and I see an x right here. So I'm going to put a 2 in that place. So where it was 4 times x to the third, it'll be 4 times 2 to the third. And then I'm going to add the 1 that you see right here, and I'm going to divide it by x to the third. But that x to the third is now going to be 2 to the third. Now, in order to evaluate it and simplify it, I'm going to follow order of operations, my PEMDAS, which says do the parentheses first. Inside that parentheses, I've got an exponent. So I'm going to do my parentheses, my exponents. 2 to the third power is 8. And remember, these two sitting beside each other, that does indicate multiplication. That's not a function notation there. That's multiplication. So it'll be 4 times that 8 plus 1 divided by 8, because again, 2 to the third is 8. Now, according to PEMDAS, I'm going to do multiplication before I do this addition. Yes, this is division, but that division also indicates fraction. I'm going to deal with the fraction after I have simplified that numerator. So I'm going to multiply first to get a 4 times 8 is 32, and then I'm going to add on that numerator. 32 plus 1 is 33, and then I'm going to try to simplify that fraction 33 over 8. Is there a number that will go into both 33 and 8? No, because the only number that will go into 33 is 3 and 11. Neither one of those will go into 8. So this is simplified. And remember, we don't care at this point about mixed numbers. We're perfectly fine with improper fractions. Always simplify a fraction if you can. Always do that. But just don't worry about turning it into a mixed number. Now, we're going to evaluate f of negative 2 at this point. So we're going to say, okay, wherever the x is, I'm going to put a negative 2 in its place. So in order to do that, now I'm going to put a negative 2 right here and a negative 2 right here. So I'll have 4 times negative 2 to the third plus 1 over, once again, negative 2 to the third. And I'll once again follow those order of operations, which say let's do that exponent before we do the multiplication. Now, negative 2 to the third is going to indicate negative 2 times negative 2 times negative 2. Remember, 2 to the third gave me 8, but negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. So instead of 4 times 8, I'm going to get a 4 times negative 8 plus 1. And again, on that denominator, I'm going to get a negative 8. Now, I'm going to do my multiplication before I do that addition. So 4 times negative 8 is going to be a negative 32. And then negative 32 plus 1, because again, this division does indicate fraction. I'll deal with the fraction after I simplify that numerator. And negative 32 plus 1 is a negative 31 divided by negative 8. Now, we do know that negative divided by negative is positive. So this really is a positive 31 over 8. And I'm going to try to simplify that fraction. Is there a number that will go into both 31 and 8? No, because there's nothing that will go into 31 other than 1 and 31. So this is simplified. And one thing that I do want to point out is a lot of people think, well, okay, if my input, if I'm just simply changing the sign on my input, certainly what that means is I'll just change my sign on my output. So therefore, f of negative 2 would become a negative 33 over 8. You saw that was definitely not the case. So don't make that mistake. When you change the sign of your input, that does not guarantee that. Go ahead and follow those order of operations and evaluate your function. Now, this one will appear very weird because it says I'm going to evaluate f of negative x. And what that means is everywhere I see an x, I'm going to put a negative x in its place. And you may be thinking, well, why are we bothering with that? What difference is that going to make? It actually makes a huge difference. So let's go ahead and pull that x out. Let's put a negative x in its place here and here. So I'll have 4 times negative x to the third power plus 1 over, once again, negative x to the third power. Now you know that negative x to the third power is going to indicate negative x to the negative x times negative x. Well, first off, negative times negative times negative is going to be negative, and x to the third power is just a negative x to the third power. So what I have is 4 times that negative x to the third power plus 1 over, here again, this is going to be negative x to the third power. Now, 4 times the negative x to the third power is going to be a negative 4x to the third plus 1 over a negative x to the third. The only thing that we're going to do at this point is oftentimes we don't like to see a negative in the denominator. How do we fix that? Oh yeah, we just multiply numerator and denominator by a negative 1. So I'm going to multiply this by a negative 1, and I'm going to multiply this by a negative 1. And basically what happens here is it just changes all the signs. So I end up with a positive 4x to the third. I'll put this over here. Positive 4x to the third. I end up with a negative 1. And down here I end up with a positive x to the third. And please understand that what was here was not necessarily wrong. It just doesn't look that great because typically we don't see a negative in the denominator. So we fix it and we put that and we get a positive in the denominator. Now here again, Why did we do all this? I mean, that looks an awful lot like what we started with, but later when we talk about even and odd functions and the type of symmetry those functions have, it will be very important to be able to put a negative x everywhere you see an x, evaluate it, and then we will compare our result with what we started with, and that will tell us whether we have an even or an odd function, and that will tell us the type of symmetry that the graph has. But that's not important right now. Right now what's important is simply being able to take these inputs, put them in for the x into the function, follow order of operations, and being able to evaluate those functions. So I hope this helps you to understand a little bit more about functions. And like I said, once you've identified that you have a function, that it's not doing this, we simply give it new notation, call the y and f of x. But what that means is whatever you see here inside the parentheses, you're going to substitute that number in for the x into your function, follow order of operations to evaluate that. So I hope that helps. Have a great day.